Howdy, everyone. Welcome to This Old Vegan. My name is Merlene Vassall. In this video, my brother, Dr. John Vassall, explains the science behind vaccines and also talks about how African Americans contributed to fighting smallpox and COVID-19. Dr. Vassall is Associate Dean of Clinical Education at Washington State University.
Smallpox is a viral infection that was first identified in the 6th century, spread through the trade routes through Asia, ultimately to Europe and to Portugal. The Portuguese were the first slave traders in the 1400s and brought Africans to North America, and with them came smallpox. In 1716, an epidemic began sweeping through Boston, and by 1721, it had killed 1 in every 40 people. But there was no treatment or cure. There was a man named Onesimus, an enslaved man from West Africa. He was named Onesimus from Onesimus is a biblical character in the book of Philemon, and he was purchased for his minister by the congregation. His minister was Cotton Mather. And for those of you who have studied American history, you know about the Salem witch trials, and Cotton Mather was one of the people behind that witch trial. Onesimus, an enslaved African, knew about a way to prevent death from smallpox. And that was by taking some of the pus bumps, taking those lesions, opening them, getting some of that pus, scratching yourself and putting that in your system. And it caused a less severe form of illness and kept people from dying. Sounds pretty straightforward, right? Well, a lot of people didn't like that idea. Getting pus from a sick person and putting it in your own skin. But so many people were dying that they felt as though they had to do something. And so Mather convinced Zabdiel Boylston, who was a physician, to try this procedure. He did try it on his son, on his enslaved persons, and on other people. And of the 242 people who were inoculated, only 6 died, which is about 2.5%, while 14% of unprotected population died. This procedure was instrumental in bringing the pandemic under control. Now, I want you to see something. This is what smallpox looks like on the hand. That's what it looks like on the face. Now, just imagine being told that you're going to take some of the pus out of one of these things and put it in your skin. They didn't have needles then. They just scratched your skin and rubbed it in. So, how many would run for that idea? Say, yeah, count me in. Yeah, you would? And I bring this up because, we hear a lot about vaccine hesitancy, with COVID and how people don't want to get vaccinated. In a situation like this, I would think twice myself. But when the option was to die, a lot of people decided this was a better option. Now, they call that procedure variolation. Vaccination, which is what we have now, is a process where a preparation of vaccine is used to stimulate the immune response against diseases. So vaccination, the process of vaccination, is introducing a vaccine into the body to produce protection against a specific disease. It can be injected, which is how most vaccines are administered, but it can be swallowed. There's the Sabine polio vaccine where they put it on a sugar cube, and you swallow it. Or sometimes you can spray. There's a Fluzone, it's called, a vaccine that you can spray in your nose against influenza. But vaccination is preparing your body's immune response for a specific disease. So that's what vaccination is. A smallpox vaccine was eventually developed. Now, the process of variolation, which is what Onesimus did isn't strictly vaccination, because he actually took the actual disease-causing agent and put it in their skin. Whereas a vaccine, they use either an attenuated agent, which means a virus that can't really get you sick, but it stimulates your immune system, and that gets your body prepared so that when the real bad vaccine virus comes along, your body's prepared for it. So the smallpox vaccine was a cowpox vaccine. It was a cow disease called cowpox, similar enough to smallpox that it caused you to have immunity against smallpox without actually getting really sick. And that's how the smallpox vaccination was developed. Smallpox has been eradicated as a result of these vaccinations. What does that mean? That means it no longer poses a threat anywhere in the world. It's been eradicated. Eliminated is different. Some things have been eliminated. Polio has been eliminated from some parts of the world, but it still occurs in other parts. Smallpox has been eradicated. It no longer occurs anywhere in the world because of vaccination. And vaccination came to this part of the world from Onesimus, who was an enslaved African man who brought this technology, I'm going to call it, to this part of the world. Now we have a pandemic. A pandemic is a spread of disease beyond the borders of the country or a population. So coronavirus has spread throughout the world. Started in China, as far as we know, and now every country in the world, as far as we know, has had it. COVID-19, COVID stands for coronavirus, that's the C-O, VI, virus, D, disease, coronavirus disease, COVID. 19 is 2019, which is the year that it was discovered. COVID-19 is a disease caused by infection of SARS-CoV-2 virus. SARS stands for severe acute respiratory syndrome. CoV is coronavirus, and number 2, and there are lots and lots of coronaviruses. So SARS-CoV-2 is the virus that was first identified in December of 2019 that causes COVID, what we now call COVID-19. It's easily spread. It's spread by coughing or sneezing particularly, and that's why you wear a mask. Okay? The common symptoms are fever, chills, cough, shortness of breath, loss of taste or smell. And prevention includes getting vaccinated, wearing a mask, quarantining when exposed, and isolating when symptomatic. What does a mask do? It does a couple things. What it primarily does is if a person is infected and they cough or sneeze, it contains those particles so they're not spread out into the air for you to inhale. So it's particularly important for people who are infected and symptomatic to wear a mask. The other side of it is if you're wearing a mask and those particles are in the environment, it prevents them from coming into your system, from getting into your nose. Okay? So that's how a mask works. It's pretty straightforward, but that's what it does. Okay? And yet people have had fights about wearing masks, which kind of don't make sense. What I am hoping is that going forward, you don't have to wear a mask all the time, but during the respiratory season, and particularly if you're in close confines with people, and especially people who are sick, who shouldn't be with you anyway, they should be staying at home, that people will wear a mask. It should become very common to see people with masks on in the wintertime. Okay? Somebody mentioned her name earlier. Who's this? Kismikia Shanta Corbett, Ph.D. So now I'm bringing you full circle. We started in 1721, and now we're in 2023 in a pandemic. We started with an epidemic. Now we've come full circle to a pandemic. Dr. Corbett is assistant professor of immunology and infectious disease at the Harvard School of Public Health. She did her research studies in 2009 to 2014 where she studied human antibody responses to dengue virus. You don't have to know what that is. She received her PhD in microbiology and immunology from the University of North Carolina, Chapel Hill. In October of 2014, she became a research fellow at the National Institutes of Health, studying novel viruses, novel vaccines against coronaviruses. So her research was already underway at the time before this pandemic hit, which was really great. She identified a simple way to make the coronavirus spike proteins that were stable, immunogenic, and manufacturable. And I'm going to go into this, not in a lot of detail, but a little bit more. Viruses, first of all, what is a virus? You know, I've got this thumb drive here that has my talk on it that I put into the computer. You know, a virus is a lot like a thumb drive. You know, if you have a thumb drive, it has information on it, but it can't actually do anything. You know, it's inert. For a thumb drive to actually do anything, you have to plug it into a system, an operating system, a computer. Once you plug it in, depending on the information that's on that thumb drive, it can take over the computer. It can do things. You know, if you have, say, a manufacturing process that's run by a computer, and you put a thumb drive in with malware, that software can take over that process. Okay? So that's basically what a simple way of thinking about a virus. It's a thumb drive with information on it. Now, when that thumb drive gets stuck into your system, it takes over your operating machinery, your DNA and your RNA, and it tells it to make more viruses. That's how viruses work. It's like a thumb drive that plugs in, okay? So what can we do to prevent that from happening? What vaccines do is at least with the COVID vaccine, what it does is it prevents that thumb drive from actually plugging into your system. It's just like if you were to plug up this port so I couldn't stick the thumb drive in, okay? So here is the virus, at least a picture of it. Inside the virus is the RNA, which is the information, you know, the stuff that's coded in your thumb drive. When it gets inside, we put the mRNA sequence for the spike proteins, which are these things on the outside of the virus. We put that into a vaccine. It goes into your system. Your body recognizes the mRNA sequence and starts making these spike proteins, just like the virus would do. Now, the difference is the virus would make a whole virus particle. It would be replicating itself. In this case, the vaccine only causes it to replicate the spike proteins, which are on the surface of the virus. So those red things are the spike proteins on the surface of the virus. So your body actually makes spike proteins. Your immune system says, these things don't belong here. Spike proteins are foreign. So your immune system makes antibodies against the spike proteins. Okay? You following me? Yeah. So now, if in fact at a later time you get infected with the real virus, your body has already prepared its army against the spike protein. It recognizes the spike protein and attacks it before the virus can get in your system. Okay? So that's how mRNA vaccines work. They tell your system to develop antibodies against the spike protein that usually allows the virus to enter your system. But it clogs up that part of the process that allows the thumb drive to stick into your system. So now you can't get the thumb drive in your system. You can't get infected. Okay? You following me? Yeah. So that's how it works. And that's the system, the mRNA system, which is a brand new type of vaccine that Dr. Corbett and her team produced. And that's why we are able to stop this pandemic, because of that technology, that new idea. Now, you hear sometimes that people are not as, okay, you have these variants. It started out with the Delta variant, and there's Omicron, and now there's others. And people are more, and the disease is spreading because the vaccine is not as effective. And the reason is because when you originally made your antibodies, whether because you had the infection or you had a vaccine, it was very specific for that spike protein. But the virus is slick. It said, well, let me just change it up a little. Let me change up the spike protein just enough that I could sneak by that immune system. And so now what we do is we have what are called bivalent vaccines, which means they have more than one type of mRNA against more than one type of spike protein. And the nice thing about this new technology is it can be modified as the viruses change. As the viruses change, we can modify the vaccine to change up with it. So that's where we've gotten to, and that's American history, that's African American history, that's all of our history.
Please share your thoughts in the comments below. Thank you for watching the video, and I look forward to seeing you next time. Take care.